Continuing with example F at the top of page 9, we need to compute the cosecant inverse of -2. So again, we need to dig up the characteristics of cosecant inverse. We need the domain and the range. Okay, back to page 7 here. For cosecant inverse, the domain, it's a little complicated. So anything, you can plug in any input less than or equal to -1 and anything bigger than or equal to +1. Okay, and then you've got this crazy range. Okay, so let me go jot this down and then we'll go through it. Okay, so here is our domain. And then the range is going to be basically the outputs, the angles that are returned are going to be between -pi/2 and +pi/2 inclusive, but 0 is not a valid output. That's what this is saying. Okay, so you got to be able to read interval notation. So here we go. It's going to be this. Oops. Okay, so let me exclude 0 as an output. All right. Okay, so one more time. Okay, for cosecant inverse, you can plug in any number less than or equal to -1, or the input can be +1 or bigger. Okay, the type of angle that is returned is an angle between -pi/2 and +pi/2 inclusive, with the exception of the angle 0. Okay, so let's translate this. Cosecant inverse of -2 is the angle in this interval whose cosecant is -2. Okay, so we need to go take a look at the unit circle based on this range from -pi/2 to +pi/2 that's corresponding to the right side of the unit circle. Okay, so if we come down here, we're looking at quadrants 1 and 4 for cosecant inverse. Okay, so here we go. We're going to be taking a look here for cosecant inverse. We need an angle whose cosecant is -2. Okay, so we need, and I'll write it out to the side here, we're looking for cosecant inverse of -2. Okay, so remember, cosecant is 1 over the y coordinate. Okay, we need to concentrate on quadrant 4 because the cosecant is negative in that quadrant. So if you look at these angles, which angle do you do 1 over the y coordinate and get -2 as the answer? Okay, well, here you go. Okay, it's going to be this angle. Okay, if I do 1 over -1/2, okay, that's going to be 1 over 1 times -2 over 1. That's going to give me the -2 value that I need. Okay, so again, you can go ahead and write down 11 pi over 6. Okay, but that is not the answer. Okay, because why not? Because 11 pi over 6 is not between -pi/2 and +pi/2. It's not in this range. Okay, so let me write that down. It looks from the unit circle that it's 11 pi over 6, but 11 pi over 6 is not in this range. Okay, so I'll write it down so it's not in these intervals. Okay, so what we have to do is find something coterminal with 11 pi over 6 that is in this range. Okay, so when you look at your unit circle, okay, think about negative angles. Okay, if your angle starts along the positive x-axis and you rotate to here, this is -pi/6. Okay, and that is an angle between -pi/2 and +pi/2. Okay, so you can get that by looking at the unit circle, or you can go and you can subtract 1 revolution of 2 pi. This is 2 pi here. It can be rewritten as, with a denominator of 6, this is going to be 12 pi over 6. That's 2 pi. So this would give you -pi over 6. Okay, so the correct angle here, the answer here is going to be, I'll put it here, the answer is going to be -pi over 6. Okay, this is the angle between negative pi over 2 and positive pi over 2 whose cosecant is negative 2. If you give me the answer of 11 pi over 6, because it doesn't fall in the correct range, it is incorrect. 11 pi over 6 is incorrect. Okay? All right, keep going here. Okay? Part G. We want the we want secant inverse of 2 square root of 3 over 3. Okay? Since we're dealing with secant inverse, okay, we need to again go get the domain and the range. Okay, so back to page 7. For secant inverse, okay, it has the same domain as cosecant inverse, okay, and the range is a little different. This time we're returning angles between 0 and pi, inclusive with the exception of pi over 2. Okay, so I'm going to jot this down. The domain here is negative infinity to negative 1, union 1 to infinity. Okay, the range is going to be from 0 to pi, but you're excluding pi over 2. Okay, so it looks like this. Okay, all right, so let's work on this. Okay, so what we're doing here, okay, we are trying to find, and I'll write it in a different color. We are trying to find the angle in this range whose secant is 2 square root of 3 over 3. Okay, so based on the range, since the angle that needs to be returned is essentially between 0 and pi, we need to concentrate on the top half of the unit circle. Okay, so back to page 7, we're looking at the top half of the unit circle. Okay, we can see that this is marked for secant inverse right here. Okay, so we're trying to figure out which one of these angles has a secant of 2 square root of 3 over 3. Okay, so let me erase all this previous work here. To do a secant, remember this is going to be 1 over the x-coordinate. Okay, and again, we're trying to calculate secant inverse of 2 square root of 3 over 3. Secant is 1 over x. Okay, we have a positive secant here. Out of quadrants 1 and 2, secant is positive in quadrant 1, so we need to look there. Okay, if you kind of do this in your head and you do 1 over the x-coordinate, which one of these angles is going to have a secant of 2 square root of 3 over 3? Well, let's see here. It looks like maybe here. Okay, let's try it. If we do 1 over square root of 3 over 2, this is going to be 1 over 1 times 2 over the square root of 3, which is going to be 2 square root of 3, but then we need to rationalize the denominator, and then that will give us 2 square root of 3 over 3. Okay, so it is the angle pi over 6. Okay, we don't need to adjust the angle because it is between 0 and pi. Okay, so we can go ahead and just write down our answer. Okay, it is going to be pi over 6. Okay, that's it, done. Okay, all right, I think last one here, yes. In part H, we want the cosecant inverse of negative 1/2. Okay, we just did a cosecant example up here in part F, so I'm going to grab the domain and range from here. Okay, so let me write this down. Domain is going to be negative infinity to negative 1 included, union 1 to infinity, and then the range is going to be all angles from negative pi over 2 to pi over 2, excluding 0. Okay? All right, so what this means when we're looking at cosecant inverse of negative 1/2, okay, if we translate this in words, this is the angle in this interval whose cosecant is negative 1/2. Okay, so we need to figure that out. All right, so let's go look at the unit circle. Okay, so for inverse cosecant, we need to be looking at quadrants 1 and 4. Okay, so we're coming over here. Shouldn't have erased that. Okay, so here we go. We're looking over here. We're trying to come up with an angle whose cosecant is negative 1/2. Okay, so cosecant inverse of negative 1/2. Okay, cosecant we know is 1 over the y coordinate. Okay, so let me make sure here. Yes, we're looking for negative 1/2. Okay, so when we're looking at the circle here, we need to stick to quadrant 4 because cosecant is negative in quadrant 4. It's positive in quadrant 1. So when you look at this, if you do 1 over the y coordinate here, do you see one of these guys that's going to give us a cosecant? If you do 1 over the y coordinate, are you going to get negative 1/2 as the answer? Okay, now be careful here. This is negative 1/2, but you would have to do 1 over the y coordinate, so that would be negative 2. That's not the same thing as negative 1/2, so that's not it. Doing 1 over, well, let's check this guy. Okay, if we do 1 over this, it would flip the fraction. Yeah, this doesn't work either. Okay, so it doesn't look like any of the angles on the unit circle are actually going to work. Okay, so we have to ask ourselves, is it some other angle that is not on the unit circle? Do we need to use our calculator? What's the deal here? Okay, you do also need to check for the domain. Was negative 1/2, is it a valid input to the cosecant inverse? Okay, we'll look at the domain. The valid inputs are numbers -1 or smaller, or numbers 1 or bigger. Negative 1/2 is in between -1 and +1, so it's actually not in the domain. Okay, so I'm going to write here that x equals negative 1/2 is not in this the domain, which is this. Okay, so since this was not a valid input, okay, we can conclude that the cosecant inverse of negative 1/2 is undefined.